Yeah. Okay. You can write. I'm just indicating the phenyl groups same side and phenyl groups opposite side. So generally, the most oxidizing group should be on top, or generally alkyl group will write on top. So most oxidizing group means which is with more number of oxygens. So here I can, if I am writing the carboxylic acid systems and carbonyl system, I must write the oxygen containing functionalities on the vertical. So this is Fisher projection, so which indicates the group's relative position, so with sp3 carbon. So you can also write in that way, so where phenyl above and below are vertical line, and OH same side, okay, and H same side, okay. So you can also write, this is also indicating that the same arrangement, okay, same stereochemistry, okay. So these are the answers for the yesterday's question, okay. So let's begin with one more topic. So if it is cyclic systems, okay, yesterday we discussed acyclic olefin. If it is a cyclic olefin, for example this, okay, and you going to treat with bromine, okay. So what could be the product? So this is what cis, and this is what anti-addition. So it will be racemic, isn't it? Cis with anti, racemic. So product we cannot write in two different ways with linear combination, Fisher projection. Okay. So we can write them in the ring flipping manner. Okay. So that you need to know how the arrangement on the cyclohexane system substitution is going to happen. So if I write cyclohexane, it will be most stable form is chair form. Okay. So each carbon is going to have one axial. Okay, this is called axial hydrogen. Okay, this is equatorial. So this substitution which is exactly towards the upside, okay, so that is called axial, or exactly towards the downside, this is called axial, okay. So each carbon is going to substitute with the axial as well as the equatorial substitutions, okay. So total 6 carbons, 6 axials will be there, 6 equatorial will be there. Okay. So this is the arrangement. So if I need to place the adjacent position, this is 1 and this is 2, 1 2 position, adjacent position in cis manner. Okay. In cis manner. So let's look into the carbon system. So this is one first position and this is second position, okay. So if I need to place same side means either they must to be above, okay, or must be below, okay. So these are the two hydrogens which are above this plane, okay, above this plane, these are the two hydrogens. So if I place these two with the same group, it can be called as cis, okay. Otherwise if I place one above and one below the plane, then it is called trans, okay. So cis means the first group, first carbon having axial arrangement, okay, and the second carbon having equatorial arrangement, then it can be called as a cis, okay. Trans means the first is axial, okay, and second is also axial, okay, then it is trans, okay. So because its bond angle will be 180 degrees, you can consider this is 90, this is 90, okay. 180 degrees. Both are perpendicular. Okay. So if not, if any other possibility, there is a other possibility also. Okay. So the second at equatorial. Okay. So let's say second at equatorial. Okay. And first at axial. Okay. Or first at equatorial. Okay. And the second must be axial, so that they will also be same side. First equatorial is downside. Okay, this is down, and down one is also this one. So one equatorial and two axial, these are also cis. Okay, so if two are equatorial, let's say this is equatorial, this is looking towards the upside. Okay, this is looking towards the upside. Okay, and this is looking towards the downside. So they are opposite to each other. So when they are opposite, they are said to be trans. Okay, so first first equatorial and second also equatorial. So these are the arrangement for trans. For trans means 1 2 position. If it is trans means it must be diaxial. Okay, 1 2 diaxial or di-equatorial. Okay, otherwise if it is cis, axial equatorial or equatorial axial. Okay, so if I want to write trans product, okay, because this is going to add up in the trans way, so I must write, so 1 2 either axial or equatorial. Let me write axial 1 2, so br and br, and equatorial, so br br. Okay, so these two are belongs to trans system. Okay, of the cyclohexane. But among these two, if it is a consideration about the major product, this will be major, because when a axial carbon having substitution, okay, axial substitution is there, it's going to give repulsion with the 1 3 position. Okay, so axial hydrogens which are present at third position. Okay, this is first position, this is second and third, this is first, second and third. So 1 3 axial systems, axial hydrogens whatever are they, they're going to repel with each other. Okay, so repel with each other. So this is called 1 3 diaxial repulsions. Okay, so this we will be going to discuss in stereochemistry also, but here it is required, so that's why I am giving all the information. So 1 3 diaxial repulsions which will unstabilize or destabilize the diaxial system or axial system. So di-equatorial will be the major. Okay, so there is a possibility of two groups, two molecules. Among that, major product will be di-equatorial. Okay, if it is anti-addition. Okay, if it is same side addition. Okay, so let me take the similar example and treated with osmium tetroxide, which is cis addition, cis diol formation. So I must write the product with cis. So if it is cis, one is above the ring, the other must be also above the ring. Okay, or one is if it is below the ring, the other must be below the ring. So axial equatorial or equatorial axial. Okay, so these two systems are can be considered as cis. Okay, so among these two, which will be more stable? Among these two, both will be equal stable, because one is axial, one is equatorial, one is axial, one is equatorial. So with the axial, it may be repulsions at 1 and 3 positions. With equatorial, it may not be the repulsions. Okay, so these two are equal energy, so either of the one can exhibit, or if I rotate this one, it's going to exactly similar to this. So these two are one and the same. Okay. So if it is asked for the cyclic systems, you need to write the products in this way. Okay. So try to understand and make a note of all these structures. Otherwise, you can take the screenshot also. Okay. So if you get to understand about this, we will be going to work out on this. Any doubts? Okay. So trans means both must be in opposite direction. Okay. Both must be in opposite direction. Means if it is one is above, the other must be below. Okay. ఒకటి పైకి చూస్తే ఇంకోటి కిందికి చూడాలి. Okay. So shall I remove this? Okay. Let me make here. Okay. So here I am taking cyclohexane share form. Okay. So if I need to write 1 to position trans, okay, so the product must be trans because it is going to add in the trans way. So if I take the planar one, initially bromine is going to form bromonium ion. So after that another bromide ion is going to attack. So one will be down the ring and other will be upside the ring. So it is indicating the trans. Okay. So that's why we consider the addition is also in the trans manner. Okay. So how to write the trans product means, so if it is one bromine is towards down, other bromine must be on the second carbon which should be on the upside. Okay. So like this. Okay. So why I am writing this one in this way means, so let's say I have taken the bromonium ion which is forming from the upper side. Okay. There are two possibilities. It can form from the down. It can also form from the upside. Okay. So if it is from the upside, next bromine is going to attack. So if it is attacking here, it must go upside. Okay. So what could be the product? So bromine is attacked from the down. Okay. And it must be upside. Okay. So this is what equatorial and equatorial. Let's say the same formed from the downside. Okay. And another bromine is attacked from the upside. So what could be the product? So this is from the upper side, it must be upside. This is coming downside, it must be this. So what happened? Diaxial system was developed. Okay. So instead of writing all the mechanisms and everything and the structures of the intermediate, you can directly write if it is trans addition to the cyclic compound, because in the cyclic olefin there will not be trans olefin. Okay, there will be just cis olefins only. Okay, if it is cyclic. So if the cis systems are there and you going to make it with the trans addition, definitely they are going to give trans product. Okay, if it is trans, it must be right like diaxial or diequatorial. If it is 1 to position, okay, 1 to position, it must be diaxial or diequatorial. Okay, so this is about the product formation. Any more doubts? Okay, so let's work out on some more example. You can take the screenshot or you can write also. So these are very important for the substitutions on the cycle exam. So make a note of this. Let's see. Yes, faster than it. Okay. So one more example. Uh, take Cl2 in your watch. So try to write the products and give its stereochemistry. Specify the positions. So what could be the answers? Is it going to give axial equatorial or diaxial or diequatorial system? Because it is trans. It is axial equatorial. Okay. Is it a cis addition or trans addition? Okay. If this is axial equatorial. If it is trans, diaxial or diequatorial. So generally diequatorial will be more stable. Hmm. Your third one. Is it cis or trans? So trans. So diequatorial will be the product major. Okay. So how to write? So if I take, so is it a HO plus H plus OCl minus or OH plus and Cl minus or Cl plus and OH minus? What is its electrophile that is forming from the HOCl? So HOCl is going to release what kind of electrophile? OH plus, H plus, Cl plus or OCl plus? A, B, C, D. If you know that, then it will be able to give whether it is electrophilic addition reaction or nucleophilic addition reaction. OH plus is not correct answer. So it's going to give Cl plus. Okay. So it is OH minus and the Cl plus will be the breakage or ionic type. Okay. So initially nucleophile of the olefin is going to attack on the Cl plus. So it may form Cl and carbon. Okay. So it may support or may not support because chlorine is less able to give the cyclic halonium ion. Okay. So if not support also, the OH minus will not attack from the similar side because of the repulsion between the lone phase and the anion. So it will attack from the downside or the opposite side. So resulting into what? One should be above and one should be below. Okay. So it is below, this is OH, this is above, this is Cl. So this is diequatorial system, which is stable one. You can also take diaxial system, okay, so which is less stable. So next, if it is K-monomer, it is cis dihydroxylation, okay. So if it is cis, one must be axial and other must be equatorial, okay. So Cl2 NaOH, okay. So what is the electrophile that is releasing from the Cl2 in presence of NaOH? Yeah, this is the same combination. So initially Cl plus will be attached to the nucleophile. So let me take the equatorial form. This is the target pattern which is stabilized. So again OH will be going to attack because it is NaOH, OH minus nucleophile will attack. So resulting into what? Okay. So these two are one and the same. Okay. So these are the products with different reagents. కరెక్ట్ రాయగలిగితే స్టీరియోకెమిస్ట్రీ మీకు ఖచ్చితంగా మార్క్స్ వస్తాయి. Okay. So there are some more examples like this. So question is, what is the structure of cyclic bromonium ion that can be formed during the reaction, and what is the product? So given that reaction, and it is going to go X as a cyclic bromonium ion and Y as a product. Okay. So option A, X is and Y. Option B. So don't follow the options, just follow the reaction and try to work out and give the product. So if you think about the options, there might be possibility of all options which will make you confused. So what could be the product? Answer B. Exactly. Okay. So B is correct answer because when it is need to attack, it can attack from the above and it can attack from the below. In this kind of bicyclic systems are there, this is exo attack will be more favor because endo attack will have steering hindrance from the hydrogen. So exo addition of the bromine is going to happen. So carbocation will also be stabilized with the exobromonium ion. Okay. So this is the X. Okay. After that, the Br minus bromide will attack from the anti. Okay. So from the downside. Okay. So if it is attacking, this must open to the top. Okay, or above side. So one bromine will be above, one bromine will be below. So this is exo substitution. This is endo substitution. Okay. So one more possibility will also be there, which is exactly similar to this. So why can't bromine attack from this side? It can. So if that is the case, exo will be this side, endo will be this side. So these two are one and the same if it is rotated. So these two are the possibilities. Okay. So Jengu asked that how H4Cl, how to say that it stands. So let's say the same reaction will happen with the H4Cl. So H4 minus and the Cl plus. This will be going to attack and it's going to form Cl. So this will be the carbocation. Okay. So will be stabilized with the lone pair. So again the OH minus will not attack from the same side because it is lone pair that's going to repel. So it must attack from the anti-plane. So that's why it is going to give trans. Okay, is it clear to you? So this is what trans. Okay. So and yesterday also I given. So all the heteroatomic species addition will be in trans. Except and homoatomic species will be in cis except halogen. Okay. So next, so we also discussed the addition of the per acid followed by the H2O. Okay. So how it is going to happen with this kind of system? Okay. So when it is a double bond, okay, here I am taking a cis double bond, okay, and treated with per acid, okay. So CO3H, where oxygen bond is there, it is called peroxy bond, okay. So that's why it is called peroxyactic acid or peroxy carboxylic acid or per acid, okay. So this oxygen is called proximal oxygen, which is the proximate, I mean near, okay. This oxygen is called distal oxygen, okay, which is distal, okay. So among these two, okay, so which will be more, uh, let's say, here one oxygen is there, another two oxygens over there, distal and proximal, okay. So the product will be epoxide if it is treated with the acid, okay. So which oxygen is going to give that replacement, means it is 1 and 2, among 1 and 2 which oxygen is going to reside on the oxygen, okay. So it is the second oxygen that's going to reside on the oxygen, sorry, olefin, okay. So which will be attacked by the olefin and is going to move, okay. So distal oxygen is the final oxygen that's going to available on the olefin system, okay. So when to stabilize, it will be releasing H plus, which is going to abstract by the, this become O minus now, so this is going to abstract that H plus. So this is going to give a similar kind of cyclic halonium ion, okay. So this is called epoxide. So once epoxide is formed, when you are treating with H2O, so it is going to have a nucleophile on the oxygen. So it needs to attack again anti, because the similar side attacking will not be happen because of the lone pair repulsions, okay. So similar side of attacking will not happen because of the lone pair repulsion. So it must attack from the anti. So if it is attacking, this must move, this must become O minus, and this will be trans, okay. So it become OH2 plus and releases H plus, that H plus will be abstracted by this. So this become OH, okay. So what happens is, it's going to give, this is cis and this is what trans addition, okay. So cis and trans, is it going to give meso or racemic? So it's going to give racemic. So, so this is what the product, okay. So racemic. So addition will be trans addition, okay, if it is per acid followed by the H2O. So this is the mechanism and this is the stereochemistry, okay. So wherever there is a possibility of unsaturation and per acid combination, it must give first epoxide, okay. And if it is opened by any nucleophile, if it is H2O, it's going to give OH nucleophile. If it is methanol, it will be attacked by methoxy nucleophile, okay. So everything will be in trans, okay. So everything will be in trans, so addition will be trans. So here it is going to give diol system, which is trans diol, which is opposite to the Bayes reagent. If it is Bayes reagent, it will also give diol system, but it will be cis in way. Okay, so this is trans. So if you want to make a meso product from this, you need to treat it with a Bayes reagent. If you want to make a racemic product, you need to treat with peracid followed by the water. Okay. Is it clear? Okay. So try to work out some examples. So this is p-butene treated with metachloroperoxybenzoic acid. Okay. Metachloroperoxybenzoic acid. This is also a per acid. So which will results into the epoxy. So what could be the product? Here I am taking hydrogen peroxide. So this is also epoxidation reagent. So is it going to give cis product or trans product? If it is epoxide. Actually, when I am not using water, it's going to give simple epoxide. Epoxide means double bond gets converted into epoxy. Okay, so whatever the groups are there, that will be there as such. So this is two metals are same side, no stereochemistry will be going to change. So if you take cis olefin, it's going to give cis epoxide. If it is trans olefin, it's going to give trans epoxide. There is no change in the stereochemistry for the epoxide formation. Okay. Once this epoxide is opened with nucleophile, then it's going to give. So it's going to give trans addition. Okay. So a trans product and trans addition. So it will be going to give meso. Okay, until unless there is no change till epoxidation. Okay, this product, if it is treated with hydrolysis or any nucleophile, this is also trans addition. Cis plus trans, it's going to give racemic. Alright, alright, okay. So this is what racemic product. This is what meso product. If it is asked for the epoxidation, there is no change in the stereochemistry because it is simple addition on the epoxide, sorry, peroxide. Okay, so it just abstract this and it become this, and this oxygen lone pair whatever is there is going to move here. Okay, so this is going to happen. Simple epoxidation, there is no change in the stereochemistry. Okay, if it is a hydrolysis, then it's going to give complete stereochemical change and the final product will be different. Okay, so why this is there is no change in the stereochemistry means this is as such as the olefin, the same hybridization, same bonding arrangement. Okay, everything will be same. Okay, so this is about the epoxidation. So work out with some more examples. So here I am writing. Mm, So metachloroperbenzoic acid is simply defined as MCPBA. Okay, so it's a abbreviation for metachloroperbenzoic acid. So X, and if it is treated with H2O, what could be the product? Okay, and the same is treated with methanol, what could be the product? Okay, and One more example treated with H2O, H2O2 and epoxide. So this is epoxide. This is also epoxide. And this epoxide again treated with methanol. What could be the product? And H2O, what could be the product? And here I am also using tertiary butanol. What could be the product? Okay. And some more examples. So what could be the product? Okay. So try to work out all these products. Okay. So and submit in the group. So we'll be going to discuss some more examples after your submission. Okay. So thank you.